Alright folks, you know it, it's time for another computer science video. Today we'll be reversing a linked list in Java iteratively. New CS learners, don't sweat it. I'll take you through this nice and slow. You'll get it at the end. I believe in you. Let's get started.
Alright folks, let's get into it. Question of the day. Reverse a linked list iteratively. Let's review what a linked list is. Recall that a linked list is just a series of nodes. So for example, let's take a linked list with 3 nodes. So in the first node, let's put the value 1. And this first node points to a second node, which contains the value of 2. Second node points to a third node, which contains the value of 3. The third node points to this x, and this x just represents null. This null means that we're at the end of a linked list, because this final node doesn't point to any other node. Okay. So we can describe each of these nodes in the linked list using the node class. So let's write that out really quickly. Call that class node. All right. What goes into each node? Well, we know that looking at the first node, for example, it has a value and it also has a pointer to the next node. So let's call that int value. And the pointer to the next node, we know that has to be of type node. So it's of type node, and let's call that next. So next represents the pointer that each node has to the next node. So it can either point to another node or it can point to null. Only those two possibilities. Okay. So our question was to reverse the linked list. Let's say we're given this list. After we reverse it, we should end up with something that looks like this. First node contains the value 3. Second node contains the value of 2. The third and final node contains the value of 1. And it points to null, meaning we're at the end of our linked list. Okay. One other thing we have to keep in mind is that the approach we're going to take is destructive. This means that, let's say they gave us this list, for example, and they wanted us to reverse it into this one. Destructive means that we change the original list in order to end up with this list, instead of making an entirely new list and making the copy look like the list that we want. Okay, we figured out what our question is. Let's dive into the implementation. Let's do this. Alright folks, let's jump right into the implementation. Let's look at a simple linked list, one with just 2 nodes. So the first node contains the value of 1, and it points to second node with the value of 2. Alright, so after we reverse this linked list, it should look like this. First node, value of 2. Second node, value of 1. Okay, 2 observations before we begin. First, our solution is going to be iterative. That means there's going to be a loop somewhere in our solution. Second observation, when we're given a linked list, they'll give us a pointer to the first node in that linked list. So let's call that pointer cur. Cur will point to the first node in our linked list. Alright, now let's think of a series of observations that we have to make that our code needs to be able to do in order to transform the given linked list to a linked list that we want. Keep in mind that the order in which we make these observations might not be the same as when we do it in our code, but there are going to be things that we have to do anyway. So let's list them out. Well, let's look at the difference between these 2 linked lists. The first one you'll see is that the .next reference for this node containing 1 is null in the linked list that we want. But here, that reference is to the second node. So the first thing that we have to do is set cur.next to null. So we can say null the reference of our first node. But after we do this, we run into a problem. That problem is that this node and the rest of our linked list is pretty much lost. There's nothing pointing to it, so Java would just destroy it. So in order to prevent Java from destroying this, we're going to have to set another pointer. Let's call that pointer next. And we have to do this before we null this reference. So something else we have to do is keep a next pointer. Don't let the rest of our linked list get destroyed. So with the next pointer, we still have the rest of our linked list. Okay, that's cool. What else do we need to do? Well, something else we need to do is set the appropriate connection So we see that over here, the node containing 2 has to point back to the node containing 1. So let's think about once we move cur so that it points to the second node. Since it's an iterative solution, cur will start out pointing at this node, and then eventually it'll move on to this node. When it gets to this point, we need to be able to have this node point back to this first node over here. But we can't do that because if cur now points over here, nothing is pointing to this node. So we face the same problem as over here, where this node would just be destroyed by Java. So one other thing we have to do is set a prev pointer. So prev would point to the node that came before cur, and then once cur gets over here, all it has to do is set cur.next back to prev, and voila, we have the same structure that we have in the linked list that we want. Something else we need to do then is keep a prev pointer. All right, so let's go back to when cur still pointed back at this first node. So this first node points over here, and then cur points over here. When do we set our prev pointer? Well, let's clean that up really quick. So cur still points over here. Well, we know that cur is going to move up here, and we want to set our prev pointer. Let's start out prev as null. Let's say prev equals null. Then, when we null the reference of our first node, we would set cur.next to prev. And prev is null, so this becomes an x. Then we know that we're done with this node. We're not going to change anything else. We want to move this cur pointer so it points at our second node. But we want our prev pointer now to point at the first node. So before we move the cur pointer, we can just say prev to point to that. So set prev pointer to the cur node. And after that, we're going to be able to move up our cur pointer. So our cur pointer now points to our second node. Good stuff. So that's advancing the cur pointer. Now you'll see, once we get over here, we're able to connect this back over here, because this step is pretty much the same thing as connect cur.next, or not connect, sorry, but sets cur.next to prev. We saw that in the beginning, prev was null. So when we set cur.next to prev for the first node, this just became this x. But now that prev is pointing to this first node, when we set cur.next to prev, cur.next will instead point to this first node. And this gives us the structure that we wanted in the list that we want after we reverse this linked list. So everything looks like hunky-dory, things are going according to plan. All right, let's look at how the code might look like in order to get all these steps out. So let's say public node, since we're going to end up returning the reference to the first node in our linked list, and let's say reverse. And remember, we mentioned in the beginning that we're going to get a cur pointer, which points to the first node in the linked list that we get. Okay, so we noticed that in these observations that we made, two things we have to do. Keep a next pointer, keep a prev pointer. So let's do that in the beginning. We can set both of them equal to null at first, because once we go into our loop, we can update them as appropriately. Okay, good stuff, good stuff. So we got node prev equals null, node next also equal to null. All right, so now we know that this is an iterative solution. We're going to have to operate on each node until we hit the end of our linked list. We know we hit the end of our linked list when cur is pointing to null, because that means there's nothing left in our linked list. So we can say, while cur does not equal to null, and as long as this is true, we'll go through the resulting steps in our while loop. And the steps in our while loop will contain most of these remaining steps over here. Okay, remember the first thing that we have to do is that for the first node, we have to know this reference. So first we have to set a next pointer to point over here. And so first thing we have to do is set next equals cur.next. Okay. After that, we have to set the .next to prev. So we can say cur dot next equals prev. All right, after that, we have our final few steps, which are to advance our pointers. So the first thing we have to do is set prev equals cur, so that prev, instead of being null, at least for the first node, it'll start pointing to this first node and it'll keep moving on as we go through more iterations of the loop. And then cur, we're going to move up to the next node as well. So cur now equals next, which we set in the first line of our while loop. All right. So we finished our while loop. We've finished reversing our list. But what do we return? Well, one thing we have to remember is that when cur becomes null, prev will always point to the last node, because prev is always one node behind cur. And so once cur equals null, prev will be pointing to the last node in the given linked list. But one other thing we have to remember, the last node in the given linked list is also the first node in the linked list that we want to return. So all we have to do is return prev. And we're done. We're returning the first node in this linked list, and this linked list is exactly the reverse of our given linked list. Good stuff. Looks like our implementation works. Let's try it out on a slightly more complex example. Alright, so we figured out the implementation. Now let's test it out on a slightly more complex example. Let's consider a linked list with 3 nodes. First node containing value of 1, second node containing the value of 2, and the last node containing the value of 3. So we want to reverse this list, and when we finish reversing it, it should end up looking like this. Starts with the node with the value of 3, goes to the node with the value of 2, ends up with the node with the value of 1. Alright, I'm going to copy this given linked list down here so we can see how we can transform this list into the list that we want. Alright, so we start with this node with value of 1, the node with value of 2, node with the value of 3. Okay, let's go over to the right-hand side and take a look at our implementation. So when we pass this list into this reverse method, you'll notice that cur will point to the first node in our linked list. So cur will point to this node. All right, let's move into the body of our method. You'll see that the first 2 lines involve us creating new pointers. Node prev equals null, node next equals null. So let's do that. So we have prev equals null, and we also have next equals null. Okay, then we get to this while loop. While cur does not equal null, we see that cur is pointing to the first node here, so cur does not equal null. This means we go into the body of our while loop. So first we see that we set next equals cur.next. So no longer is next equal to null. Next will now point to the second node. Good stuff, good stuff. All right, now we see that cur.next equals prev. So cur.next normally points to the second node, but now we want it to point to prev. But here we set prev equals null. So now this reference will become null. So we get rid of this arrow, and we represent the null with this x. Okay, then we see prev equals cur. So now prev is no longer equal to null. Prev will point to the same node that cur is pointing to. And then we move our cur pointer forward. We see that cur equals next. So cur does not point to the first node anymore. Cur will now point to our good friend, the second node. All right, we finished the first iteration of the while loop. We go back up into the conditional statement, which says cur does not equal to null. We see that cur still points to a node. It does not equal to null yet, so we go into the while loop again. Next equals cur.next. Well, cur.next is this third node, so next now points to the third node. Put next over here. Then we see that cur.next equals prev. So cur.next right now is the third node. We want it to point to prev, which is the first node. So we get rid of this reference. We put an arrow that points back here. Cur.next equals prev, so it points to the first node. Then we see that prev equals cur. So cur points to the second node, so prev will also point to the second node. Cur equals next. So cur, we're going to move the pointer up from the second node to the third node. So let's remove that. and cur points to the third node. Then we go back up into the while loop for the third time. We check if cur is equal to null or not. Cur still points to a node. It's not equal to null. We're going in this while loop the third time. Okay. Next equals cur.next. Well, you can see that the dot next reference for cur is this x, which means it's null. So now next will become null. So we get rid of this pointer. We say that next equals null. Okay. Then we say cur.next equals prev. Well, prev is the second node, so instead of pointing to null, this node, let's get rid of that, this node will now point to the second node. You can see that the structure looks a lot like the structure that we want, so looks like things are going well. Then we see prev equals cur, so prev now points to the third node, and then cur equals next. Well, we see that next has been set to null. So cur will now also be equal to null. Alright, so we're going into the conditional for our while statement for the fourth time now. Wow. Cur does not equal to null. You see here, we just set cur equal to null. So now cur is equal to null, which means we do not go into the body of the while statement. Good riddance. This is the fourth time we're checking, but we're done here. Okay, cool. Now we're finally at the return statement, which says return prev, which returns the linked list that prev is pointing at. Well, we see here that prev is pointing to the final node in our given linked list. But our linked list will look like this when we return it. Prev will point to the node containing 3, and now the node containing 3 points to the node containing 2, which points to the node containing 1. And believe it or not, this looks exactly like the linked list that we wanted to return. So, looks like we did the problem correctly. 10 out of 10. We are very good at computer science. I believed in you. Let's continue. Keep going forwards. Let's go.
Alright folks, thank you so much for watching the video. If you learned anything at all from this video, please be sure to like, comment, subscribe, all that good stuff. Leave your feedback in the comment, know how I'm doing, or I can improve, what you like, didn't like, all that stuff. Roast me, hit me up, do whatever you need to do. Alright, thank you so much for watching. I'll catch you in the next one. Peace.